at 304. And by the way, I've got Windows 11. There's a Windows 11 machine you could be using for this stuff if you wanted, although there's no terribly good reason to do that. But anyway, why, thank you. However, I tried and these things work fine in Windows 11. Windows 11 is, for all practical purposes, the same as Windows 10. All right. And this is running on simulated the right hardware. So, Lord only knows what nonsense is going on. All right, so all you're going to do here is compile a couple of simple programs and see how they look in IDA Pro. That's the point of this, to cover stuff we did a while ago in the lecture. So I'll show you how it looks, though, to do this. In Windows 10, the Start button has changed, of course, because Microsoft loves to mess with the Start button. So you click Start, and now all programs are hidden over here under All Apps. And now you finally get back to the right list, and in here you can go to V for Visual Studio. And then you can get to Developer Command Prompt for Visual Studio 2019. That's what I'm using. All right. And so I've already put the programs on here in this directory of dcomp. All right. And so the first one is print.cpp. All right. So this just prints hello, and it prints a number 2. So it just has 3 arguments for the print statement: a format statement, 2, and a string. And you compile it with CL, and then make it executable. You see it here, print.exe. So if you run it, it just prints 2 hello, so nothing too exciting. And if you look at it in IDA, you can see what that looks like. So here's IDA. And I can just choose it off my frequently used list. And I just accept the default disassembly. Disassembling a program involves some guessing. And those boxes with many options let you control how IDA guesses. But I've never used anything but the default guessing technique. And so here, as always, it dumps you in the official start of the routine, which is some kind of useless preparation stuff that does not include any of the code that I wrote. It dumps you somewhere in Windows preamble nonsense. So the way to get to the actual code that works best for me is View, Open Subviews, Strings. There may be some other way to do it, but this is the only way I know how to do it. Now you find a string like hello. That's the part of code you want, and double-click that. And that takes you to the data section, our data, where that string is stored, and the xref here will show you the code that uses it, and when you double-click that address, it takes you finally to the box, which includes the code that the developer wrote, and not all the Windows operating system preambles, which for some reason is where IDA dumps you. And here you see what that function call looks like. This push EBP, move EBP to ESP, that prepares a new stack frame. That's the preamble you'll see before every function, preparing its own region of stack memory to separate it from the other functions. Then it pushes a pointer to hello, the number 2, and an offset to this string on the stack. So there's 3 parameters on the stack in reverse order, and then it calls a subroutine, which is ultimately going to go to print. So that's just what it looks like when you make a function call. And this is real important. If you take the exploit development class, we exploit format string vulnerabilities because assembly language does not have the sense to know whether you actually set anything up or not. When you call a subroutine, it expects to find 3 arguments on the stack, so it just goes on the stack and uses whatever it finds there as arguments, whether they really were correctly set up or not. Assembler basically has amnesia. It executes every one instruction without any clue about context, whether it's appropriate to do it or not. It just does it unless it's impossible, and then it stops. So when there are circumstances where the parameters are not set up correctly, you can end up with print statements revealing information that the developer did not intend to reveal. And that's how format string vulnerabilities work. All right, so there's that one. And the next one has global and local variables. So let me open that one up here. That was glob, so notepad, glob. All right, so it has a global variable which you do by defining it up here in C++ or C. I think this is, yes, this is C++. It's not inside a function. See, these curly braces define the scope of something. So when I define something in here called int L or something, that variable only exists inside there. And when I'm outside of there, it's forgotten because it was stored temporarily on the stack in that one procedure. But this one is stored globally for the whole program, so it should be stored not on the stack, but in the data or the R data segment. So we'll see that there should be a thing holding 2 in a global variable and a thing holding 3, which is a local variable. So let's see how that one looks in IDA. And I've got it here, glob. Okay. And when you're on IDA, when you're done using IDA, it will try to remember everything you've done and save a database of it, unless you say don't save, which is what I want to do for our simple little projects here, where we're not doing like any serious analysis. We're just looking at things. All right. There we are. It's done, and it has dumped us in some stupid place. So we have to use the strings to get to a good place. Open subviews strings. And here's the %d%d, which is the only string in this one, the format string. But that gets us to where that string is stored, followed by a carriage return or a line feed. I think that's a line feed. And then we double click this, and here are finally at the real code that does the work. So here's the same preamble, and here it is pushing things on the stack. So it pushes the format string, and up here it pushes ECX, which is dword 419,000. So that's the global variable pointing to a different section. And you can see it's in a data section popping up in this box. And here is the local variable, which is on the stack. The base pointer plus a variable is probably 4. So here's the 3 for the local variable, and here's the dword for the other one. And that one, 41900. Wonder if I can go there by I can go there by double clicking that. Now I can see that's 2. And it's in the .data section. So it is just what we expected. That's the arguments in reverse order. This is the local variable, and that's the global variable. All right, and I think that's all there was to that project. Was looking at them. Oh, and then there's an unknown binary to analyze to find a flag. So you're just doing a little bit of showing how to find your way around a little bit in IDA Pro in this project. All right. Well, I guess that's for that one. Let me make a separate video for the next one.